We'd like to talk to you today about collection, data management and repatriation of archival materials back to their source communities. And I also want to begin by acknowledging that we pay respect to the original owners of the land we work on, the Gadigal people of the Eora Nation, the Ngunnawal and the Woiwurrung.
Have you ever lost a guide to a collection of image or media files? The only way to figure out what's on them is to open each one, and obviously this is to be avoided. Projects often start without first considering how the captured data that they create will be curated and described so that it meets the FAIR principles of being findable, accessible, interoperable, and reusable. This is not only detrimental to the long-term curation of the content collected, it also significantly impacts the value of the data. Crucially, it makes it very difficult for members of the source communities to get access to the materials. So archives can help with this problem, but archives can suffer from the problem of disconnected data and metadata. If we had a disconnection, the only way to recover the system is to manually inspect each item and start again. Obviously not something you want to do. So in Paradisec's collection, we have stored metadata with the data collected in a custom XML format for the last period of time. And that means that the catalogue can be rebuilt entirely from just the data store. So initially our catalogue was in FileMaker Pro, as you can see here, and that's very much disconnected from the connection. The only connection is the file name. And then we moved to an SQL system, similarly disconnected, but storing all of the metadata that we needed online. We then moved to a Ruby on Rails system, which is the current catalogue that's getting old and needs to be replaced. But with the Ruby on Rails system, we were able to write from the catalogue. Every time we saved a catalogue entry, it rewrote this file, so it's an XML file. And as you can see, you have content language, you have the name of the language, you have geography, the name of the collector, and so on. And that writes it to a file here, excuse me, which is in the collection together with the WAV file and the alarm file and so on. This then allows you to build little services. So this is what we call modularity. So we have these modules. Instead of having everything inside one big catalog system, we have modules that allow you to do different things. So in this case, we have a module that allows you to play an Elan file if it finds an Elan file and a media file with the same name, and you get this. So as you can see there, the transcript moves along the timeline in the way that Elan files allow you to do. And so we have viewers for various data types, images, text, media, and you could just keep adding new kinds of services. So if you wanted to do textual analytics, you could add those services as well. And these are called in response to the file type being accessed. So if you have a text file, then it would put up textual analytics tools. If you had a media and Elan file, it would put up the media player. We looked at existing solutions like Archivematica and Preservica. Some of them are commercial, and we were worried about using a system that was rather inflexible. And in the end, we had an existing working group here in Australia that is using Oxford Common File Layout, and we joined with them. And this all was bundled into a platform that's called Arkisto, and you can see Arkisto's URL there in GitHub. So there are two parts, the Research Object Crate and OCFL. The Research Object Crate is a way of packing data with machine-readable linked metadata and human-readable HTML file that makes it FAIR compliant, that is, findable, accessible, interoperable, and reusable. RO crates can be indexed by standard web indexes, and once found, it can be accessed and reused, informed by the metadata which is packed alongside the data. RO crate is a community effort with contributors from Australia, Europe, and the United States of America. The Oxford Common File Layout is a specification for laying out digital information on storage resources. OCFL provides guarantees of completeness such that a catalogue can be rebuilt from its file stores. It's a critical feature for us. In addition, it provides versioning and integrity checking independent from the underlying storage system. So here's an example of an arrow crate description on the left, and you can see it's in JSON linked data, JSON LD, easily read, and also there are many people who know how to work with JSON. And on the right is an example of the OCFL inventory, which has checksums that allow you to do quality assurance and integrity checking of the files. So these standards open up the data to a suite of tools being developed by others who use them as well. And in our case, we've developed a demonstrator that works on top of the OCFL file system and needs only an elastic search to make the content searchable and discoverable. All of our code is open source and free to use, reuse, and adapt. This is the ParitySec demonstrator now. And as you can see, you've got, well, because it's a demonstrator, it's not completely user ready, but it does have a lot of the functionality that we want. So we can view objects in the collection, we can search for objects in various ways, and then the objects themselves are located here, and we can go and have a look at them. So here's a view of a single item, and here you can see the metadata defined for just this item. So this is a viewer, it's not a way of editing the data, this is just a way of viewing what metadata is already there. And if you click through that item, you'll view, for example, an image of the recording, and then there will be the actual recording here. And you can see that it states what the access conditions are all the way through. One of the great things about this system is that we're able to do textual searches, and here we're searching for an ELAN file, for data within ELAN. So when we find something in this textual search, if it's an ELAN file, it knows how to play it to you. And this is in itself already a research tool, in that we can see all instances of this word in the data and we can listen to them. So if there's any question about whether or not that word has been written correctly, or if we want to see the context of that word, we can do that directly through the catalogue. You can do more detailed textual searches as you would expect, that allow you to match in different ways. So another key advantage of doing this work is that we can build sub-collections. So for example, if we went to a village and we wanted to take just the files that related to that particular language, at the moment what we have to do, what we would be doing is taking files out of the ParitySec collection, and we end up with, say, 4 items that go back to the village out of 31,000 items that are in the collection. And we need to have a way of providing all the contextual information around each of these items. So we've written a way of doing this that extracts the information, called data loader. This takes just the metadata from the object. So if we take out each object from the collection and it has its own description with it, we can then write a catalogue of just those objects. So we then have a catalogue of this small collection, and we can deliver that on, for example, a Raspberry Pi, which is a local low-powered Wi-Fi transmitter, or a hard disk. The Wi-Fi transmitter doesn't assume that people have a computer. It does assume that people would be using a mobile phone to access the materials, which is usually the case. So it's a more attractive system, and it could be located in a local cultural centre, and people could wander in with their phones, access material with records of their language. And these tools are available on our site, Language Archive Services. So this is an example of people in Iroquois village in Vanuatu. looking at their mobile phones and retrieving the information that I've created for, this is the language that I work with, Nafsan, and they're getting the records at a workshop in Iroquois Village from the Wi-Fi transmitter with no internet connection required. So building endings into projects from the start is very important, and this is something I think we need to really encourage, so that we don't just take off with projects that have no planning for what happens at the end, or if it ends prematurely, that it can still leave primary records behind. Using emerging standards like OCFL and RO Crate, I think, is a very promising way to create research objects that bundle primary data and contextual information together. And all of this creates a virtuous environment in which the data and the microservices can be shared, as the kinds of use of each is explicitly licensed with their descriptions. Thanks.